Our technology takes stem cells and combines them with digital fabrication. So in order to make bone, let's say, and you might need a piece of bone. Bone is the most transplanted human material after blood, and the only way to get human bone is to cut it out of a human, until now. So for cancer, trauma, congenital defects, if you needed bone, you'd either cut it out of yourself, that's called autograft, or you'd get cadaver bone, which is called allograft, or you'd use synthetic implants made out of, metal, plastic, ceramic, and so on. What we do is we take two things from the patient. We first take a scan, a CT scan, so that we can extract three-dimensional data out of that and understand the geometry and the perimeter of the tissue we want to grow. We also take a small sample of adipose tissue from the patient. So we take 10 ml of fat, and we extract the stem cells. They're adult stem cells called mesenchymal stem cells that live inside our fat tissue and bone marrow. We extract those stem cells out, expand them in the lab, and infuse them onto a perfect puzzle piece-shaped biomaterial that we've designed using that CT scan. And we contain the cells plus that biomaterial inside an advanced cell culture system, which we have IP on, called a bioreactor. That bioreactor allows us to feed the tissue with the exact cytokines, oxygen, nutrients, temperature, and mechanical forces that get those stem cells to attach to the scaffold, proliferate, and differentiate. It takes us 3 weeks to grow bone, takes us 4 weeks to grow cartilage. And when we're done with our processes, we have tissues that really recapitulate the tissues that reside in our bodies natively.